Hello everyone, my name is jianxiong. In this video, I will explain my approach for the energy consumption prediction hackathon. The goal of this project is to predict household energy consumption using tabular survey data, and the evaluation metric is mean absolute error, or MAE. So part one is data understanding and pre-processing. I start by exploring the dataset and performing basic cleaning. One important observation is that many numerical columns use special values such as -2 and 99 to represent missing or unknown responses. If the treats these as real numbers, the model may learn incorrect patterns. So I converted these special values into proper missing value before training. After cleaning data, I create several new features based on domain intuition. For example, the energy consumption is closely related to how living space is used. So instead of using only raw variables, I create ratio-based features such as square footage per room, square footage per person, bedroom to room ratio, and rooms per person. I also added a log transformation of the square footage feature to reduce slowness. And the part two is trying different regression models. After preparing the data, I began experimenting with different regression models. My first attempt was a simple baseline regression model using gradient boosting, using five-fold cross-validation, and the MAE was a little above 9.3, which is acceptable but not very competitive. Next, I tried tuning the model under improving feature generate energy engineering. The performance improved slightly, but the gain was still very limited. This suggests that the main difficulty of the problem might not be model complexity, but rather the distribution of target variables. So you can see the first attempt, the CVMAE is around 9.886, which is pretty high. And after the tuning, we got 9.4. Tuned with actually CVMAE is 10.43, which is even worse. So when I examined the target variables, I noticed that the energy consumption has a long tail distribution. There are many households with moderate energy use and a small number with extremely high consumptions. This makes regression harder because larger values dominate the error. To address this, I applied a log transformation to the target variable during training and converted a prediction back to the original scale afterward. After evaluating on a validation split, the real MAE improved to about 9.19, which is a meaningful improvement over the earlier model. You can see the results here, right? Right here. Part four is the learning curve and the model fit. To better understanding the model's behavior, I generated a learning curve. From the learning curve, we can see that the training and validation errors gradually converged. The gap between them is relatively small. This indicates the model is well balanced, is neither too strongly overfitting nor strongly underfitting. So the model generalized reasonably well. And finally, I trained the model with full training dataset and generate prediction to the tester. However, my validation MAE was about 9.19, and after submission to Congo, the public leaderboard score was 8.78, which is surprisingly lower than my local result. So in summary, I cleaned the dataset and handled special missing value codes, engineered ratio-based housing features, I experimented with regression models and tuning. I improved performance using a log transformation to the target. The final model achieved about 9.19 MAE locally and 8.78 on cargo. Thank you for watching. And also thank for ChatGPT for the help of the code.